Talking about the strengths of acid and bases. Weak acids only partially dissociate in water. Hydrofluoric acid is the only halogen that is a weak acid. So we are going to learn how to write equations for the dissociation of strong and weak acids. So looking at these equations, a strong acid completely ionizes 100% in aqueous solutions. Here's an example. We have HCl plus H2O or water, and that's going to turn you into HCO3 plus and Cl minus, where a weak acid dissociates only slightly in water to form a few ions in aqueous solutions. Example is H2CO3 plus H2O. And again, point out that these can go both ways, and that can end up equaling H3O plus and HCO3 minus. Strong acids. In water, the dissolved molecules of HA, a strong acid, dissociate into ions 100% of the time. They give large concentrations of H3O plus and the anion A minus. So again, drawn out in an equation, you can see here, HCl plus H2O leads to H3O plus and Cl minus. Here's a chart of common strong and weak acids. There are 6 common strong acids, and they have weak conjugative bases. Okay, so here are your strong acids. You have hydrochloric, hydrobromic, perchloric, hydrochloric, I thought I already said that, and sulfuric and nitric acid, etc. And then here are your weak acids. So they increase in strength, okay? There. Your weak acids are only a few molecules are going to associate instead of 100% in the strong acids. So most of the weak acids remain as the undissociated molecular form of the acid. So the concentrations of H3O plus and the anion are small. So again, here is your equation. H2CO3 plus H2O going back and forth to form H3O plus and HCO3 minus. Okay, so you can see weak acid only partially dissociating. Here is a table of weak acids. And these make up most of the acids, and they have strong conjugate bases. So here are, again, the strong ones that we just talked about, and here's the list of weak ones. Okay. So when looking at them together, in a hydrochloric solution, HCl solution, the strong acid HCl dissociates 100% to form H and Cl, where a solution of the weak acid HC2H3O2 contains mostly molecules of that original acid and a few ions of hydrogen and C2H3O2. So you can see the difference of 100% dissociation versus partial dissociation. Okay, so moving on to strong bases. Remember, these are the ones that are slimy. So they are formed from metals from group 1A and 2A, and these include LiOH, NaOH, KOH, BaO2, OH2, SrOH2, and CaOH2. And they dissociate completely in water. Okay, so here's an example where you have your original base and it associates down to the 2 constituent molecules. Okay, so let's apply this. So let's identify each of the following is a strong or weak acid or base. So pause me and come back. So this HBr is a strong acid, HNO2 is a weak acid, NaOH is a strong base, H2SO4 is a strong acid, CuOH2 is a weak base. Okay, let's try one more. So using that table that we identified before, identify the stronger acid in each pair. So pause me and come back. So for this one, HNO2 is a stronger acid, HBr is a stronger acid, and H3O plus is a stronger acid. Good job, guys.